All right, let's dive in. Today, we're going to try and untangle the incredible and sometimes invisible connections that power all life on Earth. And you know what? It all really comes down to one thing: energy. The journey that energy takes is way more complex and, frankly, more amazing than you might think. So let's get into it. So, to kick things off, here's a bit of a riddle for you. What could a soaring hawk and a little mushroom on the forest floor possibly have in common? I mean, one's a top predator, right? And the other, well, it's a fungus. They seem like they're from totally different worlds, but stick with me because you're about to see how they're both absolutely critical players in the very same game. You see, every single living thing, I'm talking from the weirdest fish in the deep ocean to the toughest plant on a mountain, needs energy to live. But here's the thing. The real story isn't just that they need it. It's about the incredible journey that energy takes, a journey that connects every single organism on this planet. Now we're going to start with an idea that most of us probably remember from elementary school science class. It's the simplest way to picture this journey of energy: the food chain. So, what is a food chain? Well, it's our starting point. Think of it like a super simplified diagram, just a straight line that shows the most basic path energy can take when it moves from one living thing to another. And here's the classic example. Now, the most important thing to see here isn't just who eats you, it's the arrow. That arrow is showing you the direction the energy is flowing. The sun's energy gets soaked up by the grass. The rabbit gets that energy by munching on the grass. And then the fox gets its energy by catching the rabbit. See? Simple, clean, one straight line. But to really get a handle on this flow, we need to know the official names for the jobs everyone has. So let's meet the cast of characters in this natural drama. First up, at the very bottom, we have the producers. These guys are the foundation of pretty much every ecosystem. We're talking plants, algae, anything that can do photosynthesis. They're amazing because they don't have to eat anything. They literally make their own food out of pure sunlight. That's why they are always at the start of the chain. Okay, next up, the consumers. This is basically everybody else. Any living thing that has to eat to get its energy. It's a huge group. You've got your herbivores that only eat plants, like our rabbit, and then you have carnivores that eat other animals, like our fox. And inside that world of consumers, you've got this classic, age-old dynamic. You have the predator, that's the hunter, and you have the prey, the one that gets hunted. So in our little example, the fox is the predator and the poor rabbit is the prey. A simple but super powerful relationship. Okay, so we've got the basics down, right? Producer, consumer, predator, prey. It all seems so neat and tidy. But nature is almost never neat and tidy. In fact, it's usually pretty messy. So it's time to see where this simple idea starts to break down. So let's think about our fox again for a second. Does it really spend its whole life just waiting around for one specific type of rabbit to come hopping by? No way, right? What else might it eat? Maybe some mice, a bird, maybe even some berries if it's hungry enough? Just asking that one question starts to show the cracks in our simple food chain. And that's really the heart of it. In the real world, almost no animal survives on just one type of food. Their diets are varied. So that simple, straight line we drew, it's a good starting place for sure, but it's just not telling the whole story. We need a better map. And that brings us to a much more accurate and honestly a much more exciting model. This is the food web, and this is where things get really cool. Whoa, okay, now this is a different story. Just take a second and look at all those lines, all those arrows crisscrossing. It looks messy, it looks complicated, and super interconnected, because that's exactly what life is. This is what the flow of energy actually looks like out there. This is a food web, and a great way to think about it is that it's not just one food chain, it's dozens of them, all linked and overlapping with each other. It's a way more realistic wrap because it shows that most animals have options. They eat more than one thing. So let's break this down. In a simple chain, maybe we say a hawk eats a snake. That's it. But in the web, we see the hawk also eats mice. And hey, look, the fox is also hunting those same mice, and the mice are eating the grass. All of a sudden, you see how everything is tangled together in this amazing, complex network. So who cares, right? Chain, web, what's the big deal? Well, it's a huge deal. And it all comes down to two really important words: balance and stability. I want you to imagine this whole complicated food web is like a giant, intricate safety net. What do you think happens if you reach in and just snip one of those threads? Okay, look at this. On the left, you've got a healthy, happy forest ecosystem where everything is in balance. But now, look at the right. Let's say a disease wipes out most of the deer. Well, suddenly the wolves or cougars that depended on deer for food are in trouble. And the plants that the deer used to eat might start to grow out of control, choking out other plants. See? Just one change sends ripples through the whole system. This is a textbook domino effect. It's one of the basic rules of how nature works. If a certain type of insect disappears because of pollution, it's not just a problem for the insects. Every bird, frog, or bat that relied on them for food is now facing a crisis. The whole structure starts to wobble. At the end of the day, ecosystems need balance to survive. Too many predators, and the prey gets wiped out. Too much prey, and they eat all the plants. It's that very complexity of the food web, all those different connections, that creates stability. And this brings us all the way back to our mushroom. It's a decomposer. It breaks down all the dead stuff, from dead leaves to that husk when it dies, and returns the nutrients to the soil so the plants can grow again. It's nature's ultimate recycling program, closing the loop and keeping the whole system balanced. And that, of course, brings us to the final and maybe the most important point. We aren't just observers of this web. We are a part of it, a huge part of it. We sit in countless food chains all across the globe. So the question I really want to leave you with is this. As our species builds and farms and fishes, which threads of this incredible global web are we pulling on? And what kind of ripples are we creating?